been disconnected.
Note, this session is being recorded.
They're all available.
Huh? Are we active or not?
Hello. Unmute them.
Yeah, they heard you. They send you a message. Yeah, chat. What is it?
Just wanted to make sure one is ready. Good morning, everyone. I hope we are all available and we are all connected. If anyone has an issue, please communicate. Today's session is about detailed cross-section and sub-assembly composer. This is what we shall work with today. Okay, from where we stopped last time, where we developed our alignments and profiles, the next stage would be to develop a corridor for our section, for our road. And to come up with a corridor, we need we need some assemblies, or should I say a group of sub-assemblies to develop an assembly that will be used to come up with a corridor. If I can take us back to Silver 3.
Directly sub-assembly composer. You can just
Okay.
put it into only sub-assembly composer. No simple.
Okay. Okay. So I don't know if we all have sub-assembly composer, but if I remember well, most of you I told you about it. So in the sub-assembly composer, basically we have our interfaces like this. We have this toolbox that gives us the geometry elements, which is the point, the link, and the shape, which make up our sub-assemblies. We also have, these are the major three items that we use to define our sub-assembly, that the sub-assemblies that we use to come up with an assembly. If I can go through one by one, a point, okay, let me first go through the interface. So we have the point, the link, and the shape, and we have advanced geometry points where we have the intersection point. For example, if you have two links and you want to develop an intersection, we have an intersection point. If you have a section where you have a curve, for example, if you have a chamfer or something, you can use the curve item. We have a fillet, fillet just like the way it is in the sub-assembly. We can invoke a fillet. Sorry, in Civil 3D, we can also AutoCAD, we can have a fillet as well. Then we have the offset geometry and the loop. Then the auxiliary points and links. And then we can also, as you advance with your sub-assembly composer, we have things to do with
Filemon, please share the screen.
pardon? Oh, the screen sharing is not on.
Share your screen with us.
Oh, okay. A second, please. Sorry about that. Okay. So I hope now you can access the screen, right? That is there anyone who can see the screen? Okay. So I was saying that uh, the flowchart, the when we have sections, when we have elements where we need to develop sub-assemblies with different options. For example, if just like the way we know when we are developing our side slopes, we know that when, for example, the fill is maybe less than 1 meter, according to the design manual, it has a given slope. If it is between 1 to 3, it has a different slope, and beyond 3. So if we have to make a decision and we have different categories, then we use our workflows and, for example, the decision and the switch, the flowcharts. But this is on a more complex level. But today, I think it's better we first go through the first item, which is the geometry, and which is made up of the point, the link, and the point, the link, and the shape. So if we have our sub-assembly, that is, if we need to develop a cross section, sub-assembly, it's an assembly that will maybe come up with our typical cross section for rural areas, as most of you could have seen in reports. I would say, uh, let me see if I can show you one. Get a typical cross section. Uh, okay, so if we have our typical cross section, which has a a bituminous section, a bituminous layer, a base, a sub-base, and selected subgrade, then we can develop that before we import it into Civil 3D so that we can develop our corridor accordingly. So the first point, as you're coming up with sub-assembly, we need to have our point of attachment where all the other elements will be attached. So the first item will be to attach a point. So when we attach the point, as we can see down here on the packet settings. Okay. Just again.
Go to this detail. Typical sections. Just copy this one design. Just click civil.
So I wanted us to first have a simple look at what we are going to come up with before we come up with with the assemblies that we plan to come up with.
I think I'm facing serious drops, network drops.
Okay, so hopefully everyone can see this. So I thought we can come up with this typical cross-section, this typical cross-section, and we develop an assembly for it. So as we can see, we need to have an AC layer, we need to have a base and sub-base and subgrade. And that's the embankment fill that is not right here. The side slopes have to be designed as per the design. They have to be developed as per the design. And we have our elements, the given lengths of our cross sections. So with that, I think we can come back to our sub-assembly. And the first point will be our start point. So our start point would be P1. So P1 will be the point of attachment, and accordingly we can give it a point code. The point code is what the Civil 3D will read, especially if you're linking this point to any item. For example, if you want to run this sub-assembly along an alignment, the point code is what will be attaching the sub-assembly to it, not the point number, because the sub-assembly, the Civil 3D will not does not read the point number but the point code. So the point code here, maybe we can say center line as our point code, and then since it is the origin, we can leave the rest as 0, 0, and then the rest of the elements will be attached to that. So if that is okay, then we can come to say if our bituminous layer is let's say 0. 0. If it is 0.5 0.05 meters, that is 50 millimeters. So if we attach another point, then this point to form the 0.05 millimeters, we can. Pardon? Pardon?
Should I continue? You are facing any issues?
No.
You okay now?
Yeah. So we shall have our point starting from the previous point, then we can have our delta, this delta x and delta y, that is the x and the y direction. So if we are moving down 0.05 meters, we can change our delta x to 0.05, and if it necessitates to, in this case, we shall add a link to the point so that after attaching this point, it will be able to, it is forming a separation, and these links will be used to develop the shape, because they are like separating lines for the different elements. So if that is okay, then we can add another point. That was for the AC. So if, oh, a minute, then we can name this section. Okay. The next one, we can add a connection to the P2, which will also have, let's say our base is 0.15, 150 millimeters. Then we can have 0.15 in this location, and then just a second. Okay. I hope it is being noticed here. Okay, so the previous one was 0.05, and then the next one, so it will start from 0.2, but going down, which will be negative 0.05. Then finally, we are having, if that was the base, so if we are having the sub base of, let's say 0.1175, accordingly with its link, and then that becomes negative 0.15. Okay, so this is from the start point of the point of attachment of our subassembly. We have this. So if we start on the, for example, the left hand side, there's one part where I didn't go through. We can have our, if you can see, all of you can see in this section, we have our packet settings, we have our input or output parameters, we have our target parameters, supervision, and everything. So in the section of input parameters, if we have, say, standard figures that can be used in the subassembly, for example, say the depth of the asphalt concrete, the depth of the base, if the depth of the subgrade, if these figures are fixed, then instead of inputting these figures manually the way I put them, we can instead have them set so that when we are inputting the depth or the length of the parameter or the slope, we just use the value which is defined in the subassembly. For example, if I have let's say the asphalt concrete, what is it? If I say AC is it is double, or is it, we have integer, we have double, we have the grade, the slope. So if it is an integer and is an input, and the value is let's say AC is 0.05. Now just a second. Okay, so if it is 0.05, then when I come to my point of 0.2, which was the base, then in this instance, I can remove the value which is here, which is 0.05, and I instead replace it with AC. So if I replace it with AC, it will remain the same thing, so that I do not have to keep on adding. I can also have my AC in terms of millimeters, which will be 50 millimeters. And when I come in this location, I'll have 50 divided by 100, by 1000. And in this case, I'll still have that. So this section of the input output parameter will help us to, it will simplify the repetition of putting in the values manually. And also secondly, when I have this value here set, as SC. In this instant, the value will be constant all through. But when I set it here and I go to Civil 3D, in this case, I can keep on changing. So if you're inputting the parameter here, it has to be fixed. It is a value that will not be changing. So I would prefer inputting the values and then when we reach the other side, we just input the code that we have defined for them. So if we can have the base and have the sub base, and maybe the subgrade. So accordingly, we shall have our items. Then this and sub base. And finally, our subgrade. All right. So these are our just a second. I don't know why. So as you can see, I input subgrade here, but in my definition, I had made an error. So the system can see that. So now I think you're fine. Okay. So now the next item is to develop to get our links, which are taking us either direction. So if we start on the links, the link also gives us the various items. It has the link codes and the points of which it is connecting. So if we say our link connects from our point of reference, which is P1, and and, uh, and you want it to connect to another point. If I could take us back just one, if we removed this link connection, so our link will act in such a way that if I'm moving from just a second, if I have no link, if I have 2 points and I want to join those 2 points, then I use a link. So if I have, for example, this L5, I can join from P4 then to P5, and then that will be the link will join 2 items. For example, if you don't have a link attached to a point and then you would want to have them, that is how you use a link to attach to 2 points. And in case you have a specific code for the link, for example, if it is the top surface, especially if we are going to create the top and the datum, these help us especially in determining the quantities. Then you give it a link code as well. So in this case, we have the link there. So let us first leave this link, and then we have another point which will be attached to the top point, the start point. So from P1, and now we have our point, but now we want our link, as most of you can see from our cross sections. We know that our align the slopes of the carriageway at 2.5%. So I can come and joined the first point, we know that our road width is negative is 2 point it's 3.5, but the direction is since it is an integer, it has to know the direction. So if we say we are working on the left hand side, then I have negative 3.5, and then this is where it's heading. But then we need to have slope of the road as well. So what do we do? If we come to the type of placement, we can see that we can have slope and delta x. So these angle delta x, angle delta y, angle and distance, delta x, delta y, delta x to the surface, all these can be used in different ways. So in this instance, we're going to use slope and delta x. So our slope is negative 2.5, and we know that delta x is negative 3.5. So accordingly, our top surface will have the slope that we desire. In case we have locations where this might, if in case you're going to have a predefined target or something like that, you could use the offset targets. So in this instance, if there is an offset target, the sub-assembly and the civil 3D, they will override the offset distance that you have put, in this case the 3.5, and be able to target any element that you're working with. And in this case, but because we don't have the targets defined yet, this is why we cannot select it. So if we, I wish we could do that as well. So for example, if we have left and right edge targets, we come to, we can define them. For example, we can have the carriageway left target, this is an offset target, because we can also have surface targets and elevation targets. So if this is an offset target and we say it is 3.5 as the 3.5 meters as the target distance, then we can also have the carriageway right target, which is also an offset target. Okay, so if okay, so now if we come back to our okay, so if we come back to our point that we're trying to come up with, our point and link, we can see now that on the offset targets we can target our left and right hand side. So in this case we shall get the carriageway left, which will be okay. So in case this distance is in case we want to do our targeting instead of using the horizontal distance, then the offset targeting will override the distance that we set there. In this case, we don't have these others, and then if we this will give us this point. So now, if we want to get the point, which is the base layer, and we know that just below the base layer we have our AC thickness. So in this case, when we come to this point, we can get our delta y as negative AC, as we did before, divide by 1000. And then in this case, we can eliminate the link which is joining the 2 points, because after this location we will have, if you can see from our, okay, for the pavement layer from our typical cross section, for the AC layer from our typical cross section, after the 3.5 we have a 1.5 meter paved shoulder. So in this location, it does not necessitate for us to have a link between P6 and P7, because after all, even with the other location, with the edge, with the paved shoulder, it will be the same material. So it can have the same shape. So from P7, we can add another link, which is P8, and in this case, we are trying to have delta Y as negative base divided by 1000. Also remove the link, and then same applies to the sub base. And finally the subgrade. Okay, so as we can see, after the carriageway, we can join these points with the links that we had talked about before. So shall say link 1 will join P7 to P2, to P7, then link 2 P3 to P8, link 4 joining P4 to P9, and lastly shall have P5 to P10. Okay, so after that, now that is our carriageway. So now we can move on onto the paved shoulder. From the paved shoulder, we know that if we bring back our point link and code, we move from P6, which is our origin, P6, yes, P6. If I can add on these parameters, we can have carriageway, which we can input as since it is 3.5, that is 300. We can have paved shoulder. The paved shoulder, I think we can leave it. So in this instance where we had 3.5 here as our delta x, we can change it to carriageway divided by 1000, and it will still work accordingly. So if we come to our next point, which is a paved shoulder, we know our paved shoulder is 1.5 meters, so but we are also still going to use our delta x to the slope delta x, in which instance the paved shoulder still has the same slope, and the distance, the horizontal distance, is negative 1.5. Okay. Uh, so we know that. So after this, we have I could say we can use we know we have we have a rounding surface which is not paved, and the layer below that, which is the base layer, is down, which will be 0.45 meters. So in this instant, I will get a point of intersection from this location. Uh, if we can see this point, which is point of intersection here. Before I do that, let us first get a point which is just below this, which is P12. We can have a link connected to this, because at this point the SC surface, this is where it stops. So if I get our y as negative SC divided by 1000, this is where our section stops, and then we can develop we can get other points for the not a point, we shall get a link. In this instant, we shall get a link which will connect the P2 to the P7, the P12 to the P7. Okay, now at this point we need to get the endpoint of the rounding surface for the top, that is for the base layer, and we know it is 0.45 meters. So if I come here and I join to P12 as my origin, and I have slope delta x in 0.5, and delta x is negative 0.45. We can have edge of rod in the section of the targets. We can have our rod edge, should I say left edge target, which would be in this instance an offset, and it would be a sum of the carriageway, it would be the sum of the carriageway, the paved shoulder, and the rounding, which would be around this is 5.45. That would be for the left edge. So in this instance, I can get the offset target can override the left edge, but we also have this. We can also add the link in this position because it is the top layer. All right, so now we have this, and we know now we need to develop the side slope of our pavement layers. That is on the left hand side. So for the first scenario, we are going to use the normal, which is the normal requirement by the design requirement. So I don't know if we have seen our side slopes from our Uganda manuals for the pavement layers. Let us say that we are going to take on the 1 to 2 as our side slope. In this instance, we are going to get our point, and then we can define side slope. And take the parameter to be 2. So in this case, when we come, we select slope delta y or slope delta x, we can have our side slope as this location. We can have it as our side slope. Excuse me. Okay. And we can I think it is, we need to use slope delta y. Yeah, it should be slope delta y. Okay. Okay. And we have our delta y as, we shall take on a very small value, which is, let me say, 0.01. And just a second. Okay. Why it's acting up, but okay. 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 All right. So so now, if we are taking our slope as 2 to 1, and our delta x, let us take it as 0.1. This is quite high. Just a second. So on our side slope, if we need to have this 0.8 and 0.14 intersecting, because we cannot come up with this location. We can, come up with this location, but it is much easier since this is already predefined and this item is also predefined to develop an intersection, in which case would just connect the links at the point of intersection. So if we come up to the intersection bit, we know that we're trying to connect link 16 and link 9. And we extend the links. And so this is the point of intersection. So from this point of intersection, we can join the point 15 to the point 14 and to the point 8. Sorry, should be here. Okay. 14, 16. Okay. So it's 15 and to link 14. As well as this point of intersection. This is 16 and 9. Sorry, 16 and 9. Okay. So if we come here, we shall, 15 and 14, and then we can also join point 15 and point 8. And that is how we come up with this location. Same applies to the point of our subbase and subgrid as well. Shall meet the intersection. In this case, it will be link 17 and link 10. And then we shall be able to join them from link 15 to link 16, as well as from point 16 to point 10 to point 9. And finally, we shall finish off with link 19 and link 11. So 17 and 10. Okay. So
Please note, this session is being recorded.
so that is to do with our points and our links. This is from one side. So if we come, maybe something we could use our fillet, should I say, in this location. We know that at the paved location, at the AC location here, it is not always a sharp point. So it always has a fillet at this, it always has a curve at this location. So maybe that is one thing that we could do. Hello?
Please turn on the video. Please turn on the video.
Daisy, you're saying anything?
Please turn on the video.
Which video?
I think it. Yeah.
Which video?
Because of the network, it got
Is it
disconnected.
this
Our
thing?
video got disconnected, so that's why they were asking. Now it is connected.
So you can see it now?
Maybe it's just me. It's okay. Maybe it's just me. I don't know.
No,
I'm not seeing
I can't see it either. I can't see it either.
I see Salim saying it is on.
Huh. Okay. So Maria and I can't see it.
I think
Okay, I think you should, maybe it's the connection or something, but it is on.
Okay.
Yeah. All right. So if you come to the filling part, we need to choose the first link, the second link, the affiliations, and the radius, if it is to be rounded by radius or by length. So let us see how we do this. If we have the first link as L12 and the next one as L13, it already developed this for us. I think the radius being 3, but I don't know. We can see if we can make it smaller. I hope you can see the difference. Okay. Okay, let us go with that. So this will, in the output, we shall have this location having the fillet at the edge of the AC surface. Okay, so we can now go to the shape files, to the shape. So this part of geometry helps especially to deal with determining the volumes, because, should I say, the quantities, as it gives as the way we have our subassembly now, it is a void, it has voids, and it's a skeleton. So if you wanted to determine the volume of this, if you had wanted to get quantities or determine the volumes in this using this cross section, then you will not be having any volumes, because this is just a skeleton. So it is only hollow and it has void. So we need to make it have a body to. That is what the purpose of the shape is, because it is this shape that forms the body that calculates the quantities. So I can say now, for example, if we can give them we can name the shapes differently. We can say, we can name the AC, we can name the the base, the sub base, and the subgrade accordingly. So I'll come here and say this is my SC. And mind you, when you're calculating quantities in Civil 3D, it is this shape code that you will use to, just like the way we have talked about how other point codes and, uh, and the link codes, the way they are the ones which are reflected in Civil 3D. The same applies to this. So when you're developing your quantities, it will be this that will be reflecting the other side. And if you don't use the appropriate code name, you will not be able to generate what you're trying to generate in Civil 3D. So, uh, so if we name this AC, we can select the shape, we can select the links within which this shape is going to. Uh, SubAssembly. I saved the SubAssembly.
Anyway, you can save it because what happens is the moment you click this one, it will just
So we can. It's better to save before we select our sections, because it can easily get stuck. So if we come here, and so if you select the point, it will select the void, which is the void which is should I say enclosed, and that is, and it will bring for you the links accordingly. So okay, so as we can see, we selected this void and it has brought us this area which is enclosed. If in any case there was a section along this skeleton that was not joining to the other, it would certainly not be able to select these links.
Please note, this session is being recorded.
Just a second. So this is our AC. This is our AC. So now if I get the second one, if I get second shape, in which case I'll say we could easily select the links connecting this, and it will be the same thing. So here, if I pick this void, this will be our base, and this is our sub base. Finally, we can have this as a subgrade. Okay. Okay. So now this is our left hand subassembly of our pavement layers. A few things maybe that we could talk about before. I think the other side will be able to do it yourself. We can talk about when I told you that when we import the sub-assemblies back to Civil 3D, for example, when you're developing a corridor, uh, the point and link codes are important in joining these, because you see a subassembly is just a cross element that joins. When they're joined at different frequencies, they come up with a corridor. So now for these points to join, they need to have the same identification, they need to have the same coding. So when we came here, for example, if we start from where we started from, uh, we had this as centerline as our code. So that means all the points will be joining by the centerline accordingly. But now, if we come to the upper link, for example, the upper link can also have upper link can have a, it can have a code, as well as the point can also have a code, and these will help. And when you import these in CO3, these will be the points that will join. For example, if you want to get the top surface of the road, we need to have the link and that the top link all having the same code for them to be able to develop a uniform, to develop a corridor the way you want it, and to give you an output that you want. So in that instant, we tend to have the same codes. For example, if this is the carriageway on the left hand side, if this is the edge of the shoulder, edge of the paved shoulder, we give them the same codes. This will remain the top surface all through, and maybe this will be the datum. And if we need to develop the volume of the of the pavement, then the volumes can be developed accordingly. So when I say code, for example, you can say this link code can be the top, and this will apply to all top links. And we say the point code here could be let me see, you can call it edge of the, should be carriageway, left. You can say carriageway left. Okay. So if come here, we can, the code can be, this is still the top surface. So this is the top, and the point code in this instance would be the paved shoulder. It will be the paved shoulder, and still on the left hand side. And this link, since it is still the top surface, this P12, it will also have, it will also be a top link. And the P12 is, we named, okay, this was the carriageway left, then paved shoulder, then this location, this is also the top link, and the point code for the last point in this location could be the road, should I say road edge left, but can get something. Let's say the left edge. Okay. L17 is also a top link.
Philemon,
Yes, please.
I don't know whether I'm a bit behind. I need to ask, when we are plotting these points, for example, for the top layer, we base on the length of, for example, the carriageway, the shoulder, the walkway. That's what we base on, right?
It is the top surface of the road, the way you see it.
Okay, the top surface. What about, these are all surfaces, right?
Oh, okay.
Oh, these are, sorry, the layers.
The links. What? Okay. The bottom of the pavement layer is the one which is the lower surface. But the way the road is, the way you see it from when you're on the road, the way you see it from above, the way you see every point that you can see is the top surface of the road.
Every point. Okay, this is it's a cross section, right?
Exactly.
So what I was asking is, for the top surface, it's understandable. Like you're plotting points, the length. Like for example, L would be the length of the carriageway, right? Point, for example, point 1 to point 2. Then point 2 to point 3 maybe would be the shoulder or something like that. What I wanted to ask is, what about the other layers? What do you base on to plot those points for the lower layers?
Which lower layers? Oh, the lower layers.
Yes.
The way the lower layers came up, they were they came up relative to the top layers. Because for example, you see, we said from point 1 to point 2. Okay, now to get point 3, we went down the depth of the base. But for us to, when we came to, the same applies when the carriageway, when we came to the top part, the carriageway, we went down the depth of these layers. But when we reached at this location, we had this as our end of the surface, end of our AC surface. And we knew that we have a length of 0.45 as our widening, as our rounding off. Now, after reaching this point, given that we knew the side slope of our pavement layers, now we intersected this side slope with the next pavement layer, because this already has a link. So we can intersect this to develop this. I don't know if it's what you're trying to ask, how to come up with these locations. Is it what you're trying to ask? Yeah.
Yes.
So we use the intersection tool to intersect the link which is coming from this position. This one I made it short, particularly for that reason, so that it can intersect this and this link which we already had from before. This one, we joined these links were joined by joining the points which were from the depth from above, from the previous pavement layer. So now if I join this link and this other one, I came up with an intersection point here, which is P15. P15 is our intersection point. So then I can use my links to join this and this. The same applies to this. Now L17, which is our new link, would be connected to L10, and we shall invoke this intersection point. The same applies to this.
All right. Okay. Next question. Like, I don't know whether I told people this, but if I decided to just design this in the normal Civil 3D interface or in AutoCAD, would it be wrong?
No, it's not wrong. But then should I say the purpose of SubAssembly Composer is to develop your own, to come up with your own, to come up with assemblies with your own predefined, the way you have predefined them. You will not go to the Civil 3D and find it the same way you want to use it here. I don't know if you get
Okay.
it. And then you'll find you need
Yeah.
to adjust a few items. If you went to Civil 3D templates, the way they are there, you have to first adjust them, I think. And I think it takes much more time to adjust them to come up with something that you want. This would be much easier to me.
Okay. Okay. Thank you.
Okay.
I have a question. Philemon.
Yes, please. I'm getting you. You ask.
Okay. Now, from this very end, where link 21 ends, on the at point 17. I understand that is that where we are supposed to attach this cut and fill condition?
Which at point 17?
Yes, at point 17.
Yeah.
Okay. Will you be able to teach us how to do that cut and fill using the decision part of the workflow?
I don't think not today.
Oh.
Yeah.
Okay.
But I think we shall go through maybe one set of cross section which has that decision making. But this we need to first come up with basic subassembly.
Okay, thank you.
Okay. Are your questions over? Okay. So these, as I had said, these will be our top links, and the lower section will be our datum. If you check in your Civil 3D and usually in the corridors, it notices the top and the datum surfaces because they are the ones used to come up with the volumes. So you need to preset your top and your datum accordingly. So the same procedure as we have done here is repeated now for the left hand side, and most of you might be looking for mirroring. Not get it here. You have to do it and repeat the same procedure, and then after that this sub-assembly can then be imported into Civil 3D and then can be used as a sub-assembly to develop your corridor section.
Muted.
I think let them do just at least one whole assembly and then what we can do, bring up a new session on Monday or something. And even if they can complete it by tomorrow, to afternoon, we can have a session. This starts today.
Unmuted.
Okay, so I don't know if we can have this done by the end of tomorrow, by end of today or tomorrow, so that we could come up do another session concerning this. Maybe now we can try to add other elements about subassembly composer, and also see how we, if possible, I don't know if tomorrow or next week, we see how we import this into our Civil 3D and how they function as well. I will need your comment about this. I don't know. When do you think you guys can have a complete set with both the left and the right hand side? You could tell me. Am I speaking to people?
Yes, maybe around Tuesday next week, if it's not very far.
Tuesday, what are you doing? This small item here. I think if you guys can, you can have it by end of today or by first half tomorrow.
Anyway, yeah.
It is not big. This is not quite big.
Salman?
Yeah.
Hello? Salman?
Yes.
Some of us, okay, I have not had electricity, I've not had electricity for like the whole of today. So I do not know when it's going to come back, meaning I can't use the computer right now. So, yeah.
You tell your many people to put for your electricity.
I will.
Okay,
We'll try.
Okay, Monday, can we have a session on Monday afternoon?
Yeah, Monday is fine.
Yeah, but let us have a complete set.
Okay, it is fine.
I think also template like one we have. Okay. All right. I think we shall do Monday afternoon, but let us have it complete. And, say something. And if there are any questions before we finish up, please you can ask.
I wanted to ask when are you going to upload the recording?
What happened? You are not following.
The network is jumpy.
Okay, let us see as soon as possible. All right, then I think we can call it a day.
Thank you very much.
The meeting.
Muted. Please note, the session recording has stopped.
The attendance will always be there.
Now, this I am installing this system also. Okay, so you need to keep this one. Stop it.